Assalamu alaikum. Inshallah, we are dealing or presenting our section in the our last section in the chapter and the last section in the course completely. Okay, it's an interesting topic though. Suppose that we want to have, it's the previous sampling distributions were for normal. We are assuming that the original distribution is normal, so we based on normal distributions, based on normal population, you can say, based on normal population. We built or we based we found the sampling distribution. The sampling distribution of the mean. The sampling distribution of, number one, the mean. The sampling distribution of the mean x bar, we learn that it is normal with mean mu and variance sigma squared over n for infinite population. We are talking, also we learned that this is the sampling distribution of the mean, knowing in the mean sigma is known. Here we assume that sigma is known. Okay, in the case of the sampling distribution of the mean, in case sigma is unknown, okay, in case sigma is unknown, then we introduce the t distribution. And then the t distribution, which is will be x bar minus mu divided by sigma over root n. And in place of sigma, because it is unknown, we replace it by s. Okay. Alright, and from here, and we can standardize the x bar. We have x bar minus mu divided by sigma over root n, in case you standardize it. But here we assume the sigma is known, so we can compute the z probability. If the sigma is unknown, then we will deal with the t distributions. And this has a t distribution with n degrees, with n minus 1 degrees of freedom. T has a t distribution with n minus 1 degrees of freedom. Okay, and then after the t distribution, we define another distribution that is based on a normal population, as the chi-squared distribution. Chi-squared distribution with the new degrees of freedom. And if y has a chi-squared distribution with the new degrees of freedom, and then this distribution will be in the form of it's a ratio of standard. The t is the ratio of a standard normal divided by okay. We define the t distribution, okay. We define the t distribution as the ratio, okay. Sorry. Usually the t distribution is defined as a ratio of a standard normal divided by a chi-squared over its degrees of freedom. Z had, we assume it's normal 0, 1. And y, this one is a chi-squared with the newest degrees of freedom. Y and z are independent. Okay. But their application, the main application of this theorem is knowing اللي هو sampling distribution of the mean in case sigma is unknown. Now another theorem that is يعني we use it in case of normal population is to compare the variance ratio. Okay, another one for the يعني useful for normal population in them based on normal population is the one for the variance ratio. Number what here? Number 3. The variance ratio. Okay, and this here we compare, we have two normal populations. Okay, we have you can say we have x, the x1 to xn, and then we have x1 to xn. This is a random sample from normal with mean mu and mu1 and variance sigma 1 squared. Okay, and have another sample in y1 to yn is a random sample from normal population with mean mu2 and variance sigma 2 squared. Okay, we want to check whether the two populations have equal variance or not in them. So we want to test check whether sigma 1 squared equals to the sigma 2 squared. The two populations are equal, and then we will ايش يسمونه, we get to use اللي هو الF test, and then we will base this on, and then base decision on the F ratio, of S1 squared divided by sigma 1 squared over S2 squared divided by sigma 2 squared. Okay, and this will have an F distribution with n1 minus 1 degrees of freedom into minus 1 degrees of freedom. Okay, so all of the previous tests, they were based on on normal distribution. So we have distinct hypotheses regarding to the mean. Okay, the sampling of the distribution of the mean is normal when sigma is known. Then when sigma is not known, then the sampling distribution of the mean will have a t distribution of the n minus 1 degrees of freedom. We can use if you have two populations, normal populations, we can compare their variances, and the variance and the test statistic for this equality of variances, then will be the F test. Okay, now some statistics, they don't need you to base, you can still do testing in them, but you don't have to base on normal distributions in them. So, and on the contrary, when the samples are small, and this happens when it is expensive to obtain, and then it could be measuring is expensive in case of cancers patient or diabetes patients. Okay, the population tends to be not normal. The population values, the population distribution tends to be not normal. So in this case, I have to choose the statistics, and then that they do not assume normal population, and then statistics that do not assume normal population do not assume normal population are called non-parametric statistics. Non-parametric statistics. So the normal, the statistics that is based on a normal population called parametric, and the one which do not assume normality are called non-parametric. Okay, so the one do not assume normal population are called non-parametric statistics. Among them is the orders among يعني one of we identify in this شو يسمونه section, and then we identify a class of non-parametric statistics called order statistics. A class of non-parametric statistics is known as ordered statistics. What is the concept here? What is the concept for order statistics? Okay. What is the concept of the order statistics? Suppose that I have, they illustrated the idea here, and then to be more simplified the idea, and then simply consider the case when n equals to 2. Okay, consider the case. I have a sample of 2 values. The case n equals to 2. Okay. Then, if I let y1, I let y1 to be the first order statistics, and to be the so I have suppose that I have a random sample, and then my random sample x. Suppose that the random sample is there's 2 values, x1 and x2. Okay, we let y1 to be the smallest, and then first smallest. We let the y1 be the first smallest. Okay, as the smallest. Okay, value. And let y1 be the random variable, and then be the value of the random. Let y1 be the variable having the smallest value. Okay, let y1 be the variable having the smallest value. Because it is variable anyway. Be the variable having the smallest value. And we let y2 and y2 let y2 be the variable having the largest value. Then what would I have? Then I can have this scenario. Okay, then I can have this scenario. It could be that y1, the smallest, is x1. Okay, and y2, the largest, is x2. In the case, this will happen in the case where I have x1 is less than x2. Okay, this is the case when x1 is less than x2. Or I can have y1 is x2 and y2 is x1. Okay, So the smallest is x2 and the largest is, is x1. This will happen when x2 is less than x1. Okay, so this is in the case I having اللي هو two random variables, اللي هو x1 and x2. So it could be y1, the smallest could be x1, or it could be y1, the smallest is x2. Now when I have a random sample of size 3, then for the case when I have a random sample of size 3, consider the case when n is 3, and I have a sample of size 3. Okay, then my original variables will be x1. Okay, the original set of variables will be x1, x2 and x3. Okay, x1, x2 and x3. Then we will have first now for the y1 could be any one of them. Okay, then I will have the following scenario. Okay, I will have the following scenario. y1 is the smallest, y2 is the second, y1 is the next largest, and y3 is the third largest. Okay, so we will set, and then we will set y1 to be the smallest, y2 is the next largest, or second largest, you can say, then second largest, y3 is the third largest, then okay, so y3 is the next largest. Okay, y3 will be the third largest. I would like to say it this way. Okay, so I can have one of the possibilities, and then can have the scenario يعني إن could be إن y1 could be x1, y2 could be x2, y3 could be x3. This happens when x1 is less than x2 less than x3. Okay, I can have y1 x1, but I can have the second largest is x3 and the third largest is x2. This will happen when x1 is less than x3 less than x2. Okay, I can have y1 is x2. Okay, so here we will permute them. Okay, permuting اللي هو three values. We're permuting 3 values will be 3 factorial. I have 6 cases, right? Set of all permutation could be, and I can have y1 is x2. Okay, y2 could be x1. Okay, and y3 could be x3. So here will be x2 is less than x1 less than x3. Okay, I can have y1 x2, and I can have y2 x3, and I can have y3 x1. Okay, this will happen when x2 is the smallest, next to smallest x3, largest is x1. Okay, I can have y1 to be x3, y2 could be x1. Okay, and y3 could be x2. Okay, so in this case x3 is the smallest, second largest x1, and the third largest is x2. I can have the smallest x3, y2 is x2, and y3 is x1. In this case the minimum is x3 and the maximum is x1. Okay, clear? Now we want to know what is the probability density, and then we want to know the probability density of the rth order statistics, and then you just need to know the theorem. Okay, see, when you find this derived High theorem, you will have to think of them, they are ordered. Okay, they are ordered. Here you have the YR order statistics. Before it will be the Y sub R minus 1, and here you have the Y1. So before a number of variables less than YR will be here R minus 1 variables. I have YR is a 1 variable. Then from YR plus 1 to Y sub n, the largest, I will have n minus R random variables. Okay, accordingly, the probability density, what does the theorem will have? Okay, we can write it later on there. See, for these variables, they satisfy in x is less than y sub r. Okay, they had a range. In this range, for these variables, I have x is smaller than the rth order statistics. I'm focusing on the rth order statistics, on this one, y sub r. Okay, so I have r minus 1 random variables, then they are smaller than y sub r. Okay, and I have here in this side, I have n minus r random variables, then which are greater than y sub r. Okay, they are x variables, but these x variables are greater than y sub r. Okay, so in case now it's clear to how to derive the formula, and then for the rth order statistics, the theorem says that for a random sample, for random samples of size n and from an infinite population okay, that has the value f of x at x, the probability density, okay, the probability density of the rth order statistics y sub r is given by, okay, is given by GR of y sub r equals to. To derive the هذا شو يسمونه is easy. You know that I have a total of n variables, which I am permuting. Okay, I am permuting. So the number of permutation will be n factorial, and then I will divide by r minus 1 factorial for the number of variables that are less than yr, 1 factorial for the variable that is the rth order statistics, okay, and n minus r factorial for the variables that are greater than y sub r, I have here for this set of r minus 1 variables, x is less than y sub r, a probability of x less than y sub r. This will be, you know, the integral. Then let us write it as the probability. Okay. The probability of x less than y sub r. I have it power r minus 1. Okay. Times I have the probability density at y sub r. Okay. Times I have for these variables x is greater than y sub r. Okay. And how many they are? n minus r. Okay. And they are independent. So this will give me اللي هو a probability of x greater than اللي هو y sub r power n minus r, because they are n minus r and they are independent. Okay, so we can simplify it as gr of y sub r equals to n factorial over r minus 1 factorial into n minus r factorial. Okay, if you want to write it 1 factorial, you can have it, and then into a probability of x less than y sub r is the CDF. We assume a density continuous. We assume a variable continuous. Okay, so here will be the f capital at y sub r. Okay, power r minus 1 into density at y sub r. Okay, into a probability of being greater than y sub r, and then greater than y sub r is 1 minus a CDF. So this part will be 1 minus f capital at y sub r power n minus r. Okay, y sub r will take the same values of x, and then we'll take the same range of values within x. So minus infinity less than y sub r less than infinity, and these values will be based actually on the values of the original variable from which we sampled. And so accordingly we can derive let's say this is notes or remarks. Okay, we can derive اللي هو شنو ال probability density of the maximum and the minimum. Okay, خلاص, now we have order statistics. My order statistics will be y1 less than y2 less than y3 less than yn. They are ordered. Okay, these are my order statistics. Some books they write them as they use the notation x sub 1 for the first order statistics, x sub 2 for second order statistics, and so on, less than x sub n for the largest order statistics. The probability density for the smallest order statistics, and then the probability density of the smallest order statistics is given by easy. Each time, you remember, you don't have to memorize, and then you don't have to memorize. You have, this is the line, y1 will be the first value, second will be y2 up to yn. Here you have n minus 1 values, and here you have 1 value. So g1 of y1 will be n factorial divided by 1 factorial into n minus 1 factorial, a density at y1, and a probability for these variables. Okay, for these variables you have x is greater, for all of them they are greater than y1. Okay, greater than y1, so it will be 1 minus CDF at y1. 1 minus f capital at y1 power n minus 1. For y1 any value يعني taking the same values from the population. Okay, you can simplify this, will be just n. Okay, g1 of y1 will be n into f at y1 into 1 minus f capital at y1 power n minus 1. For minus infinity less than y1 less than infinity. We write it down here. Okay, now we derive the density for the maximum, and then density for the maximum, the probability density for the maximum, for the largest order statistics. Or the maximum. Okay, and in case for the maximum, okay, I having this is yn, and before it I have yn sub n minus 1, and here y1 I have smaller than the maximum n minus 1 random variables, and it accounts for itself total n variables, and this will give me gn of yn. Gn of yn. It is n factorial divided by n minus 1 factorial into 1 factorial. A probability into the probability of a variable x here. In this part, x is less than y sub n. For all of these variables, I have x is less than y sub n. Okay. If I focus on, my focus is y sub n, all of them they are less than y sub n. So probability of x less than y sub n will be f capital at y sub n power n minus 1 into density of f at y sub n. So this will reduce to gn of yn equals to n into f of yn into CDF of x fyn power n minus 1 for minus infinity less than yn less than infinity. Okay, now next will be we derive the probability density of the median, and then the sampling distribution of the median, the sampling distribution of the median, in case I have a sample as of size 2m plus 1 يعني يكون odd. In case the sample is odd, and then I will have what? The median is in the middle, taking one position. Before the median I will have here n variables. Okay, after the median I'm having here n variables. N variables are smaller than the median, and n variables are larger than the median. Okay, in this side x is smaller than x delta. Okay, my focus is x delta. Okay, and in this side I have x is greater than x delta. So So in this case, the density for the median, will be, we call it h of the median. Okay, h of x delta will be, I'm first permuting all of these variables. إنزين اللي هو بيكون عندنا ال n factorial, and the n factorial, it is just 2m plus 1 factorial divided by m factorial into 1 factorial into n factorial multiplied by the probability of x to be less than x delta, less than median. إنزين this will be اللي هو f capital of x delta power m multiplied by the density at the median, اللي هو f at x delta multiplied by the probability of x greater than the median, اللي هو 1 minus f of x delta power m. Okay, the median will be for minus infinity less than median less than infinity. It will be one of the values, and then one of the values of the variable. Okay, now let us have an example. We will illustrate using the exponential function. This is the most simplest function with the order statistics, and then it says that let's show that then. خلينا نقول if suppose that I have a random sample of size n from an exponential distribution. Then for a random sample of size n, of size n from an exponential population with the parameter theta. Okay, find the sampling distribution of find the sampling distribution of number 1 the minimum of the minimum and the maximum and the median. y1 to the maximum, yn, and 3 the median x delta. Okay, all right, now let us start. You know that if x is exponential theta, if I'm sampling from a population from if x has exponential theta distribution, okay, then f of x will be 1 over theta a power minus x over theta for x greater than 0, and it will be 0 what elsewhere. Okay, we need to compute the capital F, يعني the CDF, probability less than any value of x. Accordingly capital Fx, okay, the probability being less than x, will be the integral probability of x less than x will be the integral from minus infinity to x f of t dt. Okay, and this would equal to the integral of from 0 to x of 1 over theta e power minus t over theta dt, okay, which equal to 1 over theta e power minus t over theta divided by minus 1 over theta, okay, from 0 to x. Alright, so this will give me, you know, e power minus x over theta minus 1, and multiplying by minus, it is 1 minus e power minus x over theta. Okay, so this is the CDF of the exponential distribution. Accordingly, we can find now the probability density for the minimum, then the density of the minimum, density of y1, the first order statistics. Okay, I never memorize it. I picture it in my mind all the time. So it will be y1, and from y2 to yn, I have n minus 1 variables. I have here 1 variable, and g1 of y1, g1 of y1 will be n factorial divided by 1 factorial into n minus 1 factorial density at y1 into a probability for these variables, the x for this set here, x is greater than y1, into probability for x greater than 1, it is 1 minus CDF, 1 minus f capital at y1 power n minus 1. This will simplify g1 of y1 will equal n into f of y1 into 1 minus f capital at y1 power n minus 1. Okay, طبعا y1 is any value from the population which is exponential. y1 is a variable from the population which is exponential, so it has, you know, y1 is greater than 0. Okay, my population values, they are all greater than 0. Now I substitute at this step. At this step, I know my density. This is my density. Instead of x, I write y1, and I use the capital CDF, and instead of x, I'll substitute y1. Okay, so it will be n into 1 over theta e power minus y1 over theta. I substitute it into the density, okay, into 1 minus e power minus y1 over theta power m minus 1, and here also I substituted for y1. Okay, so I will get the answer as n over theta e power minus y1 over theta. Here simple algebra, l1 will cancel l1, and minus into minus will be positive, and then I will multiply power by اللي هو الباور, multiply power by power, I get e power minus n minus 1 into y1 over theta. Okay, and then I simplify further, I add the powers together. Okay, n over theta, I have the same base. When I add up these two exponents, I have minus n plus 1. So plus 1 y1 over theta will cancel اللي هو minus 1 over y1 over theta, and we'll end up having only e power minus n y1 over theta for y1 greater than 0. So this is the density for, you know, this one and 0 elsewhere. This is the g1 of y1. Okay, the density for the minimum, the sampling distribution of the minimum. Okay, next we go for part 2, finding the sampling distribution of the maximum. Then sampling distribution of the maximum of yn, the maximum. Okay, same thing as before. Okay, Same thing as before. I don't memorize. I always lay them down, you see. This is my y1, this is my yn, okay? Now, I want to have the distribution of the yn up to yn minus 1, and then I have here n minus 1 random variables, yn counted as one variable, total n variables, and density here of yn, gn of yn will equal to n factorial divided by n minus 1 factorial into 1 factorial. For these variables, for this set of variables, and then they are all less than x is less than y sub n. Okay, all of them, they are less than y sub n. So the probability of less than y sub n will be, you know, a CDF. This will be the CDF, F capital, at y sub n power n minus 1 into density at y sub n. Okay, so this will simplify to n into F capital at y sub n power n minus 1 into f of yn. Sometimes they wrote it in this way, and f y sub n into f capital at y sub n power n minus 1. And y sub n is one of the values I'm sampling from, you know, exponential, which is greater than 0. يعني y in here is greater than 0. Okay, substitute for exponential density. Substitute for exponential density at y sub n. It will be 1 over theta e power minus y n over theta. Okay, into a distribution function is 1 minus e power minus y sub n over theta power n minus 1. Okay, for yn greater than 0. And that's it. Yani, this is you collectively gn of yn, it is n over theta, no more simplification, e power minus yn over theta into 1 minus e power minus yn over theta power n minus 1 for yn greater than 0 and 0 elsewhere. Okay, next, the joint density between the maximum and the minimum. Oh, sorry, we need to get the density, the probability density for the maximum. Our third item is the probability density for the maximum. The probability density for the median, sorry. The probability density for the median. Okay, the probability density for the median in case I have a sample size and then 2n plus 1 sample size. Odd يعني يكون. Okay, again I draw it and then I assume that I don't memorize the formula. Then, so here will be the median at this position. Before the median, I will have n variables, and after the median, I will have n variables. For this set, for the first set of variables, here x is less than the median, and here x is greater than the median. Okay, so the density for the median, h for the median, will permute them all to n plus 1 factorial divided by n factorial into n factorial, and the probability of x less than the median will be the CDF power n times the density at the median times اللي هو the probability to be greater than the median 1 minus f capital X delta at the median power m. Okay, طبعا الميديان is one of the values, it is greater than 0. Okay, we substitute. I have 2m plus 1 factorial divided by m factorial into m factorial. Its CDF is 1 minus e power minus x delta over theta power m. The density 1 over theta e power minus x delta over theta. Probability of greater than fx delta will be e power will be here 1 minus e power minus x delta over theta power m. Okay, here we cancel ال1 with ال1 and you get e power minus x delta over theta. يعني you subtract 1 from this quantity, 1 minus this quantity, it will be only e power minus x delta over theta. Now we will multiply the powers here and then we'll add the 2 powers there. Okay, and this will give me 2m plus 1 factorial over m factorial into m factorial into 1 over theta e power minus, I will have m plus 1 into x delta over theta into 1 minus e power minus x delta over theta power m. Okay, for x delta is greater than 0. Alright, so in this way we finish this exercise. There is another theorem also regarding to the sampling distribution of the median. Okay, but there is a theorem that says the following. The theorem says that for large n, the sampling distribution of the median sampling distribution of the median for random samples of size 2n plus 1 is approximately normally distributed is approximately normally distributed okay, with mean mu delta, okay, and the variance and the variance 1 over 8 into f of mu delta squared into n. What is mu delta? We define here we need to define اللي هو population median. The population median is in the population median mu delta is defined as it is the number satisfying or it satisfies as the number, is defined as the number satisfying the equation, the integral from minus infinity to mu delta of f of x dx is half. يعني 50% of the area is to the left of to the left of the median. 50% of the area of the population is to the left of the median population. Okay. In case of the population is normal, the mean is equal to the median. For this, what all the theorem in simple words, in other words, what this theorem says, it says that the median, the sampling distribution of the median, in case you have sample size is 2n plus 1, is it 2n plus 1 sample size. The median will converge to a normal distribution with mean mu delta and with a variance 1/8 into f at mu delta squared into n. Okay. If I am sampling from normal population, if I'm sampling from normal population, from a normal population, I would have the mean equal to the median. Okay, the mean equals the median equals to the value of the mean. Okay, and in this case, f at the median will be the same as f at the mean. Okay, which is 1/√2 by sigma. Okay, 1/√2 by sigma. So this would imply that in case for normal populations, in case for normal populations, and then I would have the median will converge to normal distribution with with mean equal to mu. Okay, with mean equal to mu, and the variance for it will be 1/8 into the value of the density at the median will be 1/√2 by sigma whole squared into n. Okay, if I simplify this quantity, this would imply that in the median will converge to normal with mean mu and variance اللي هو by sigma squared over 4n. Okay, compared to the mean of this population. Okay, to the mean of this population, which has size, compared to the mean, the sample mean, sorry, خلينا نقول compared to the sample mean. Compared to the sample mean. And in a sample size of sample 2n plus 1, and then compared to the sample mean, and then if I sampled from normal population, إنزين الإكس بار the sample mean will converge to normal with mean mu and variance sigma squared over small n over the sample size, but sample size here is 2n plus 1 over 2n plus 1. Okay, now if you compare these two variances, if you compare the sampling distribution of the median to the sampling distribution of the mean, okay, you will notice that the mean will have the smaller variance compared to the median. So the mean, the variance of the X bar and the variance of the X bar, the asymptotic variance of the X bar is smaller than the variance of X delta. Or you can say this one we use less than the variance of the median. Okay, the variance of the mean is less than the variance of the median, لأن the variance of the mean it is sigma squared over 2n plus 1. هاي الفاريانس عبارة عن by sigma squared over 4n. Okay, sigma squared, this is almost approximately 0.5 into sigma squared over n. Okay, and this is approximately 0.785. I guess by over 4. By over 4. Okay, equals to 0.785, yes, into sigma squared over n. Okay, so in this case, if I'm sampling from large populations, and then I'm sampling from large populations, so for large samples, from normal populations, it is more reliable. The mean is more reliable. The sample mean is more reliable than the sample median. And this will finish for us our talk for today. Wish you all the good luck.